All right, so the first section, 1-1, graphs of equations. All right, first of all, learning targets. You guys are going to do these things, okay? You're going to sketch graphs of equations. You're going to find x and y intercepts. We'll talk about symmetry and what that means in terms of graphs. We'll talk about this all year long in terms of odd and even functions, so we'll get there. We'll find equations and sketch graphs of circles, and we'll use equations to solve real-world problems, a few of those as well. Once again, everything from this class is really stuff you've learned before in Algebra 2, so I don't think there's going to be a whole lot of new stuff, but it does require repetition, as you guys know. So first example then, this says example 2, but this is the first one we're going to do, is just to sketch a graph of this right here. I know you did this back in Algebra 1. This is a graph of a line. So I'm going to put this in y equals mx plus b form. Now, if I put it in that form, I can move these terms. So it's going to be negative 3x plus 7. So there, it's in y equals mx plus b. I know my slope is negative 3, and I know my y-intercept is 7. So if you go to sketch that, 1, 2, 3, 4, 5, 6, 7 is right here. And this has that's your y-intercept. And then your slope is down 3 over 1. Down 3 over 1. So there's your sketch. Nothing special, but there it is. All right, the calculator, you guys have the TI-84. You can plug this in. You can also use Desmos.com or other websites, but plug it in and you can see the graph on your calculator. We're going to use this all year long. We'll use features from here, so we'll use things like the table, for example. If you go to second graph, you'll have an access to all the infinite points that are on this line. We'll use that feature throughout the year as well as many other things. But there's the graph, y-intercept of 7 and a slope of negative 3. Okay, next is the graph of an equation. So let's look at, next is intercepts. Let's look at intercepts. All right, so intercepts of a graph right here. Okay, so intercepts, it is possible for a graph to have no intercepts, like this, this parabola right here doesn't have any x-intercepts. It does have a y-intercept here. All right, this has this cubic function we're going to learn about throughout the year. We'll have 3 x-intercepts. It can have 1 or 2. We'll get to that. This is a sideways parabola, the inverse of a regular parabola. We'll talk about all these functions, but this has 2 y-intercepts, 1 x-intercept, and this circle here has no x or y-intercepts. All right. So let's do an example then where we identify these x and y-intercepts. So here's a cubic function. We're going to talk about translations in this class as well. I don't know if you remember that from Algebra 2. But this is a cubic function that's been shifted up 1 unit. We'll learn. And if we want to find the intercepts, the x-intercept is where y is 0. So this point right here is where y is 0. So if you plug in 0 for y, you can solve this algebraically. You can subtract 1 from both sides. And then you can take the cube root of both sides. Now the cube root of -1 is -1, so the x-intercept is -1. You can take the cube root of a negative number. We're going to learn and talk about all year long that we can't take an even root of a negative number. We can take a cube root of a negative number, we get -1s. That is how algebraically you can find your x-intercept. Your y-intercept, you just plug in 0 for x. All right, so here's your x-intercept, and I'll put that as an ordered pair, -1, 0. Your y-intercept, you plug in 0 for x, and you're going to have 0 cubed plus 1, which gives you 1. So that's 0, 1 as an ordered pair for your y-intercept. All right, so you can find these things algebraically. Obviously, you guys can find them from your calculator. So if we graph this equation in our calculator, you guys can find these by simply going to second calculate. And we're going to do, in this case, 0. So number 2, we're going to scroll to the left of the 0, hit enter. We're going to scroll to the right of the 0, hit enter, and hit enter for the 3rd time, and that gives us our x-intercept, or our 0, which is -1, 0. Our y-intercept, to find that now, we're going to go second calculate value and just plug in 0. All that does is it plugs in 0 into your x value and gives you the y value when you hit enter. Okay. So there's your y-intercept. Okay, we'll talk about symmetry throughout the year. This graph right here has x-axis symmetry. We won't see a whole lot of that. But we will talk about symmetry in terms of even and odd later. For example, a parabola has y-axis symmetry, so this is going to be an even function. So you don't have to write this down right now. This is something we'll hit later. Here's an odd function. Odd functions have symmetry around the origin. So we'll talk a lot about that. All right. We're going to skip these graphical tests for symmetry now. So we'll get back to symmetry, like I said, when we do even and odd. All right. Here is a quick example of a parabola that you can see these coordinates here. This is an even function, meaning that when you plug in 2 or -2, you get the same y value, and that y value is 2. All right. So don't worry too much about this for now. We will cover this later, like I said. All right, so another example then is a graph of an absolute value function. I know you covered this back in Algebra 1 and Algebra 2, but to graph this, this has been translated 1 unit to the left. So 1 unit to the left, you're going to have this absolute value function like this. All right. If you're not sure on how to sketch a graph of that, you guys can always make a table. One thing that always works is to make a table and just graph some points. So if you plug in -3, -3 minus 1 is -4. It goes positive with the absolute value. If you plug in -2, you get -3, which goes positive. So now I've got these points. -3, 4, -2, 3. I'm sorry, I sketched the graph wrong. This thing has been shifted to the right 1 unit. So my mistake. It looks like this. So -3, 4 is up here. -2, 3 is right here. And then -1, if you plug in -1, you get 2. And that point's right here. And so on. So you guys can always sketch any graph in this class by making a table by hand. So, yeah, that's always something you're going to be able to do. You can also use your calculator. In your calculator, you're going to go to Math. And you're going to do number, absolute value, x minus 1. And you're going to hit enter and take a look at the graph. All right, so it looks like what we described. And all those points that we were just plotting in our table, if you go to second table, you can see all those points there. All right, so this is just sketching a graph. Basically, this is just a warm-up lesson of a lot of things you've already learned, just trying to get you guys going again. I know it's probably been a long time since you've done this. All right, the last thing for this section that I want to review with you guys before you start the homework is on circles. The circles comes from a distance formula, so this is actually a proof of the formula for a circle and where it comes from. If you just make a circle in the coordinate plane and call the center HK and the radius R, and then any point on the circle, this point over here would be XY, and you plug it into the distance formula, so do the distance formula between these 2 points, the center and that point XY, and just all you do is plug it in, and that gives you the standard form of equation of a circle, which is right here. So not hard to prove this formula, where it comes from. It is the distance formula. All right, but you do need to know this. I put this on our formula sheet, so let me pull up our formula sheet real quick. Okay, so under chapter 1, this is all in order, by the way, so you won't use the prerequisite formula as much. I guess you could use the distance and midpoint, but you might have those memorized. We won't use the sum and difference of 2 cubes very much, but now we're in chapter 1. So here's the equation for the circle. It's the only formula in chapter 1 that I put on there. It's the only one that you're going to need, but I've got the formula as well as what the center and radius are. So the type of problems you guys are going to do with circles are like an example like this, where I give you 1 point, and I tell you it's on a circle where the center, HK, is here. All right, so the standard form equation of a circle is x minus h squared plus y minus k squared equals r squared, right off our formula sheet. All right, and we're just going to plug in. So it's x minus h is -1. K is 2. And then they gave us 1 point. This point 3, 4, they didn't give us the radius. They gave us this 1 point. I'm going to plug this 1 point in for x and y. So 3 goes in for x, and double negatives go positive. So I'm going to make this 3 plus 1. And then y is 4. I'm going to plug in 4. And that will let me solve for the radius. This is the distance formula, once again. So basically all we're doing is find the distance between these 2 points. So it's 4 squared plus 2 squared equals r squared. So we have 16 plus 4 equals r squared. R squared equals 20. So r equals the square root of 20. And that's really all you need to do, because now we can write the formula or the equation for the circle. All right, we'll do x plus 1 squared, right? Because I'm using this right here basically. The only difference is I'm plugging in r. So x minus negative 1 is really x plus 1. And then I have y minus 2 squared equals. Now the square root of 20, when you plug the square root of 20 in right here, it becomes 20. Because the square root squared goes away. So the square root of 20 squared becomes 20. All right, so there is my equation for the circle. All right, you do have that feature in your calculator as well. Honestly, I don't use it very much, and you probably won't either. But if you pull up your calculator and you go to apps and you go to conics, which is 4, circle, you can use standard form equation of a circle. And in this case, our h was negative 1. And our k is 2. And then our radius ended up being the square root of 20. Second square root 20. And you can always graph it from there. You just hit graph. I know it doesn't look like a circle. It looks like an ellipse. But that's because you don't have a rectangular window here. This is a circle. All right. Okay, that's all I have for you guys. You can start the homework now. Hopefully this video helps you get started.